Hello guys, welcome back to my channel MNR KRISHNA. In previous video, I have given you the first 5 questions in assignment 7. In this video, I am giving you the remaining answers for 6 and 5, 7 and 8 questions. Before going to video, please subscribe my channel and hit the bell icon. Guys, this is the code first. I'm very happy to announce that our channel reached the crossed the 100 subscribers. I'm very happy. I want much more support from you guys. Please support me. And then here is the code for 6th to 8th questions. Consider the following Verilog modules for D flip-flop and its corresponding test bench. Here it is the normal Verilog code for D flip-flop and it is the test bench code for D flip-flop. For this is the highlighted by blue color. In normal Verilog code, Q and Q bar are the outputs, D, clock and reset are the inputs. Here we for this D flip-flop we are using negative edge clock. So then input to T, okay, Q is equals to here initially Q is equals to 0. Sorry, if negative edge clock, then Q is equals to 0, else Q is equals to D. The meaning of this D flip-flop code, if reset pin, if reset is high, then the output will be 0 anyways, and Q bar is a 1. If reset is low, that is a 0. If reset is equals to 0, then output will be the input. Input means here D. Here we are using negative edge clock pulses as a clock input. So now we have some idea on D flip-flop. Then move to the test bench code. Here time scale is 1 nanoseconds or 1 picoseconds. Okay, then module DFF TB inputs. Here inputs are D and clock and resets. These three are represented in registers. In test bench code, we don't want to define the inputs and output ports. That's why we have defined the inputs as registers and outputs as wires, because the inputs we want to store the input value in previous state also. Here instantiate the design under test. Okay, at this statement we have instantiate the DFF. This is DFF model DFF DUT Q dot Q of out, Q bar of out bar. Here out means Q, out bar is equals to Q bar, in is equals to D. Here Q bar, D, clock, reset are the inputs and output ports of the normal DFF Verilog code. But in case of DUT, Q is represented as out and Q bar is represented as out bar in this code. Initial begin, here initialize inputs. Here initially the clock is 0. Forever hash 10 clock is equals to clock bar. This means for every 10 seconds, here time scale is nanoseconds or picoseconds. We are taken as, let us assume that time scale is nanoseconds. So here forever hash 10 means for every 10 nanoseconds the clock will be changed. The clock is equals to clock bar. So here end initial fork. Initially the D is equals to 0. Reset is equals to 1. For reset is equals to 1, the output will be 0. We know that. And after 13 nanoseconds, reset will be 0. Then here after 13 seconds also reset only change. D doesn't change here. That not mentioned here. So we have taken D as 0. After 18 nanoseconds, D is equals to 1. Okay, then so after 18 seconds, D will be the high. After 37 seconds, the reset is equals to 1. Here after 13 seconds, after 13 nanoseconds, reset is equals to 0, the output will be the D. That is Q is equals to D. In general Verilog code, used block assignment. That is, it is a block assignment here. Q is equals to 0. D. Join in module. So first question regarding to this code, the values of reset and Q at t is equals to 21 nanoseconds are respectively. We have to find the reset and Q states at a time is equals to 21 nanoseconds. For this we have write timing diagrams theoretically by using this code. So first let us take a reset. So here reset, regarding to the reset, for initial fork at time is equals to 0, at t is equals to 0, the reset is 1 up to 13. From 0 to 30 nanoseconds, the reset is 1, and 13 to 37 reset is equals to 0. After 37 nanoseconds, the reset is 1. So we are written that here 0 to 13 the reset is high, so it is 1. From 13 to 37 the reset is equals to 0, that is low, and from 37 onwards the reset will be high. Okay, then what about the clock? Let's see that. So just see that regarding to the clock, where is the clock? Here is the clock. Initially the clock is equals to 0 forever. For every 10 nanoseconds the clock will be toggle means toggling. If at t is equals to 0 clock is low, at t is equals to 10 nanoseconds the clock is 1. After 10 nanoseconds the clock is 0. Like that the clock pulses are going here. From 0 to 10 the clock is 0. From 10 to 21, from 20 to 30, 0. From 30 to 41, from 40 to 50, 0. Here we have the clock pulse also. Next move to the D, that is input. At t is equals to initial fork. Initial means at t is equals to 0. At t is equals to 0, the D is 0 up to 18 nanoseconds. After 18 nanoseconds the D is high, so then there is no defining about the D, so that is the D. For D 0 to 18 the D is very low, the D is in low state. After 18 nanoseconds the input is 1 for every time. Okay, then here we have the 3 inputs. By comparing from these 3 inputs we got the output Q and Q bar. For reset we know that for reset is equals to 1, the output will be zeros 0. That is, if reset is equals to 1, always output Q will be 0. So from 0 to 13, from 0 to 13, it is 0. And one thing is, guys, in given code, the the D flip flop using negative edge clock. So for negative edge clock, here the negative edge clock is here only. We have the negative edge clock here only. So at this point, we have the output up to this. The output is 0. Up to this, the output is 0. After that, the output is equals to input. Here, from this point, that is at t is equals to, from the t is equals to 20 onwards, the output is the applied input. So applied input is D. Here D after 20, the D is 1. So the output is 1 here. And at t is equals to 37, the reset is goes to high, so the output will null. So here the output is 0. From 37 onwards, the output is 0. The Q bar is not operation of Q. Okay. For 0 to 20, the Q bar is equals to 1. For 20 to 37, the Q bar is 0. For 37, from 30 to 7, the Q bar is 1. Here we have the timing diagrams according to this code. Then first question is the values of reset and Q at t is equals to 21 nanoseconds. At t is equals to 21 nanoseconds, we have to found reset and Q. Let's try that. At t is equals to 21, it is the 21. Here it is 21. At t is equals to 21, the reset is 0. So reset is equals to 0, and Q is here high, that is equals to 1. So at t is equals to 21, the reset and Q are 0, 1 respectively. So the 0, 1 is in option B. Okay, then the values of reset and Q at t is equals to 32 nanoseconds are respectively. At a 32 nanoseconds, it is 32. At 32 nanoseconds, the output, the reset is 0, and the Q is equals to 1. So 0, 1. The answer is 0, 1. So 0, 1 is option B. It is available in option B, so we have to take that. For a question, the values of reset and Q at t is equals to 50 nanoseconds. At 50 nanoseconds, the reset is 1, and the Q is 0 here. So 1 and 0. So I think these are the correct answers for these questions, guys. Please do your own and comment your answers, guys. And like the session. Still now you have not subscribed my channel, please subscribe Keep supporting me, guys. I have an idea also. Okay, then comment your answers. That's it from my end. Thank you, guys. Thank you very much.